All right, 7.2 in your textbook, page 391. We're talking about angle properties of polygons. Our goal is to apply the exterior and interior angle properties of polygons. So we have to talk about two different types of polygons, convex polygons and concave polygons. For the most part so far, I think up until this point in high school, you've been only dealing with convex polygons. Okay? And the definition of a convex polygon is a polygon with every interior angle less than 180. Any straight line through it crosses at most two sides. Okay, so here's a good example drawing. So if I were to draw any line through here, not just that line, but another line here, I'm only going to touch 2 points. Okay, and there's no angle inside here that's greater than 180. There's no obtuse angles. All right. If, however, we're talking about a concave polygon, we have a polygon with at least one interior angle greater than 180. A straight line through it may cross more than two sides. All right, so you can see here, it's kind of a Pac-Man shaped figure. If we draw a line through the mouth of Pac-Man, we're actually going to cross at 4 points. Okay, so this is an example of a concave polygon. So very important that you guys understand the difference between the two, because it will change the problem. Okay, if we're talking about convex versus concave. Okay, so another part of the definition for concave is we have at least one interior angle that's greater than 180 degrees. Okay, so does anybody know where that angle is? Yep.
Very inside of Pac-Man's mouth.
Yes, exactly. So this angle here is greater than 180. Remember, 180 degrees is a straight line. So if we go a point that's greater than that, you have to be bending open. Okay? So this inside angle is less than 180. This outside angle is greater than 180. So in a concave polygon, it's an interior angle that's greater than 180. All right? So you have that sort of bending open, but it's on the inside. So another example would be something like this. Okay? That angle there is greater than 180. Okay? And then of course I could draw a line straight through here, which would cross 4 points. Okay, any questions there? All right. Whenever you see sort of a mouth opening, you know it's going to be concave. Definition of an exterior angle. The angle formed by extending the side of a convex polygon. So the angle between any extended side and its adjacent side. Who knows what adjacent means? Adjacent means? David?
The angle
Sorry?
or the angle like next to it.
Yeah, or the side. In this case, we're talking about an adjacent side, right? So it's a side that's next to it. So the angle formed by extending a convex polygon, the angle between any extended side and its adjacent side. So we extend it, so it's this angle between this extended line and the adjacent side, which is right here. So there's your angle. Okay? I don't think anybody struggles with definition of exterior angle. It should be pretty simple. You're just taking a side, extending it, and then drawing the angle in. Okay? Any questions there? All right, so you guys did the investigate on Friday. Let's talk a little bit about it. How are the exterior and interior angles at each vertex of a convex polygon related? So I'll write that here. How are How are they related? What did you guys find out in the investigation? How does an exterior angle relate to its interior angle? So how does this angle relate to this angle? Yeah.
The sum is 180.
Sorry?
The sum.
Good. The sum is 180. So the angle of the interior angle plus the exterior angle is equal to 180 degrees. Good. Very good. What conclusions can you draw about the sum of the exterior angles of any convex polygon? Anybody get that far? So of a convex polygon, which we know looks like this, what conclusion can we conclude about all the exterior angles? Yeah?
Angle 360.
Good, so very good. We're gonna show that again. So if you don't remember that, we'll show it again. All exterior angles Very important that you guys know that and understand that. So even though we have an octagon here, we have 8 sides, its exterior angles are all going to be the same sum as a triangle. Okay, hopefully we'll see that when we go through these examples. Okay. So what is the sum of the exterior angles? So in order to do that, one of the things we can do first is to find the sum of the interior angles. If we know the sum of the interior angles, we can figure out how many angles they are, divide those by the number of angles there are, then we'll know how much each interior angle is, and then we can find out how much each exterior angle is. Okay, so first let's start off finding the sum of the interior angles. Who remembers the formula for that? Yeah.
N minus 2 times 180.
Very good. Okay, so n in this case is what?
Number of sides.
Number of sides, and in this particular shape?
8.
Good. 8 minus 2 times 180. So we have 6 times 180. That's equal to what?
1,000.
1080?
Yeah, 1080.
1080.
Same thing, 1080.
1080. So now we know the sum of the interior angles. So we want to know, because we don't know necessarily if this is a regular octagon. I don't think it tells us. Oh, it does say it's a regular octagon, sorry. So we know that these angles are the same, and we want to know how much they are. So how can we find out, if we know all of them sum up to 1080, how can we find out what each value, each one individually is? Cross.
I'll divide 1080 by 8.
Good, excellent. So then the 1080 divided by 8 is what?
135.
135? So we know that each angle inside a regular octagon is 135 degrees. Okay? Now it says, what is the sum of the exterior angles? So let's find out what is the value of one exterior angle. So if the interior value is 135, Mark, what's this exterior value going to be?
45.
So it's going to be 180 minus 35, right?
Yeah.
Good, so it's 45.
So it's not 135.
135.
Sorry, 135. And it's 45. Excellent. So now we know one exterior angle is 45. How many exterior angles are there, Jacob?
8.
Good, 8. So we know 8 times 45 is equal to what? 360. Very good. So we know then that the sum of all the exterior angles of this particular shape is 360 degrees. Let's look at a triangle, much simpler. What's 120 minus 60? Or sorry, 180 minus 60?
120.
Right, so this much easier. What's the sum of all the exterior angles? 120 plus 120 plus 120. Again, we have 360 degrees. Of a rectangle, 1 second, Josh. Again, we know this is going to be 90. This is 90, 90, and 90. So again, I'm going to add up those 90 times 4, 360 degrees. So what can we conclude then about all exterior angles of polygons? Yeah, Philippe. Yes, very good. So Josh told us that at the beginning. All exterior angles of convex polygons are equal to 360, and there we've showed you some evidence of that. Josh, you had a question? No? Okay. Example number 2. It says, determine the measure of each exterior angle in a regular 11-gon. All right? So, the exterior angle, we know, it doesn't matter how many sides, we know it's going to equal to 360. Why? Because we've just determined that here. So we can say then that 360 degrees divided by 11 will give us the exterior angle. Okay? And it's important then, each exterior, and it's important that it does say regular 11 gons, so we know all those angles are the same. Okay? So each exterior angle is about 33 degrees. And they say about because this divided by 11 is actually 33.3 with a bar on top, right? So it's a little, not quite. All right, example 3. It says determine the measure of CBA. So, one thing I do want to go over with you guys. This is very important. If you're not familiar with the nomenclature and how to read the vertexes of triangles and how that corresponds to the angles, you're going to have a very difficult time on this test. So paying attention now. When I say angle, CBA, very important because people are going to get confused here. Okay? It's an easy way to think of it is it's always the middle letter. That's the angle that you want to look at. However, there's a possibility sometimes they can be different angles, right? So if you just look at B, you could be talking about this angle or this angle. So that's why they go to a nomenclature of 3 letters. Okay, and the way you do it is you follow the letters and you'll find out which angle they're talking about. So CBA, you have to go from C to B to A, so you know it's this angle. You guys understand that?
Yeah.
So then if I say angle CDE, angle CDB, you have to know what these angles are talking about. So you follow them. C, D, E, they're talking about this angle. CDB, CDB, they're talking about this angle. Okay? Is there a difference between angles CDB and CDA?
Is there a difference in what, sorry?
Is there a difference between CDB and angle CDA? No, there isn't. Okay, they're the exact same angle because A and B lie on the same line. Okay, but just very important that you guys understand that. You guys get that? Okay, good. So it says determine the measure of angle CBA. So we want this exterior angle. Sorry guys, let me just finish up. So if we can find this interior angle, we can get that exterior angle. So the way to find this interior angle here is we take 180 minus 50, we know this is 30. Now we know 180 minus 100, we know this is 80. 180 minus 80, this is 100. Okay? Alright, stopping there.